First, let's take a closer look at this particular item. This is a small OTG adapter, and this is a USB female port where you can easily plug in a USB device. This is a multifunctional interface, and this one is Type-C. This is the micro USB interface, and this is the one I need right now. Now let's take a look. Why do I need to buy this OTG adapter? It's because of this Raspberry Pi, the ZeroW model. It currently only has this interface, simply put. I can't connect my keyboard, but let's take a look at this thing. Here, where my finger is pointing, it says Raspberry Pi ZeroW version 1.1 model. It says it was made in 2017. The W model means it has Wi-Fi functionality, but through the official imager software to flash the system, every time I boot it up, there's no Wi-Fi. So I don't know where the problem is, and I have to connect an external monitor and an external keyboard, then use the terminal application to run my shell commands in order to check why the Wi-Fi is not working and to check its model. After checking, I can even use shell scripts, also known as SH scripts, to configure the Wi-Fi in real time. I need to make sure the Wi-Fi is working before I can install and use Docker to set up our home smart home system, as well as install the ESP home service with Docker. This morning we talked about this being the Raspberry Pi 3B model with 2 GB of RAM. I deployed PVE on it, but I don't recommend using it this way because the memory is too small. Although I can install the full version, here I'm just using this mini Raspberry Pi to test whether 500 megabytes of RAM is enough to run our Home Assistant smart home system using Docker. This white keyboard is an old one I found, not sure if it still works. And this is the USB plug for the keyboard. I'm going to film it now. This is the OTG adapter we bought. Then connect the USB female end of the OTG adapter to our keyboard's plug. Now we can use this micro USB to plug into our Raspberry Pi ZeroW. Let me plug it in first. As you can see, this is the one I plugged in. Because its interface is relatively small and specialized, it is not supported. It is now Type-C. After plugging it in, I can connect this keyboard through it and then connect our keyboard to this end. HTL mini cable. We can use OBS to check our current terminal configuration. Only after the Wi-Fi is configured can we remotely SH. Okay, here's an HDMI cable that you can use for this monitor, just as you requested. Let me know if you need any help connecting it. Let's look at its two ends. This end is a standard large HDMI cable. This one is for the Raspberry Pi. The smaller end is used on the Raspberry Pi. Then we plug it into the Raspberry Pi. As you can see, I've already plugged it in now, making sure that the connection is secure so the device will work properly without any issues. Here I also need to use another accessory called a screen capture device, which is used to capture and record whatever is displayed on the screen, allowing me to save or share the visual content as needed. I've found it. One end of the screen capture device is USB. And here it has an HDMI female port. I'll plug the HDMI cable we just used into this capture device. Then plug the USB into our computer so that our OBS can capture the Raspberry Pi's data. Alright, I've already removed all the other accessories. Now we're officially moving on to the system flashing stage. Note, this isn't a tutorial, I'm just documenting the process and sharing it along the way. Here I'm using a 32GB TF card. Let's take it out. Here, just a moment. This is what it looks like when you take it out. I could have used many SanDisk cards, but I need to look for it. I'm going to look for my cards now and gather them all together. I think if you really want to use it, 32GB might not be enough. It's better to have 64 or even 120GB, but it doesn't need to be super fast even if you use the highest end ones. Even if you use the fastest TF card, its speed will still be limited to that of an ordinary card. I'll look for it in a bit. Okay, these are the TF cards I've found so far. Actually, I probably bought dozens of them before, but now I can only find these few. The rest are missing. This one works too. Let's look at the order. This is the one I first used to flash the system. It's just a regular 32GB TF card, and it's very cheap. As for brands, there's this SanDisk one. If you have requirements, it's best to get class 10 or above. This one is A1, which is equivalent to class 10. Both of these are 32GB, but this one is a bit more expensive than the blue one because it's from SanDisk. There's also a 64GB card from an unknown brand, and this SanDisk A264GB card I just mentioned. For older devices, especially Raspberry Pi, just use an ordinary card like this. If you use this kind, it's fine. Although its read and write speeds are a bit higher and the quality is a bit better, its read and write speeds are still limited. So your maximum limit is set, which means using an ordinary one is just right and much more practical. The extra performance just goes unused. And then this is the 32GB one I mentioned. I think 32GB is a bit too little, while 64GB might be just enough. For example, if I want to install some Docker containers or store a lot of sensor data, like with ESP Home, including some files, so using a 128GB card to set up a system is the best choice. It can be used for storage as well. Each Docker container, for example, might take up 3GB or 5GB for several images. It can also store dozens of gigabytes of files and data, and the system itself takes up several dozen gigabytes, so that's roughly how the space is used. 50 or 60GB, and then you still have some redundant space left. For example, if you want to use it for a year or two, say you have 10 temperature and humidity sensors, and then you have other devices, like 10 more of something else. Air quality sensors, and also some light sensors. So for example, if you have 20 or 30 of them, and you're collecting data every day, and doing this continuously for a year, the amount of data can be enormous. That's why it's best to use a larger memory card to expand your storage. Next, I'm going to try using this card, though I'm not sure if it still works, to flash the system for our Raspberry Pi, the Raspberry Pi Zero. To simply flash the system here, you'll need this USB card reader device. We insert it into the card reader, and then plug it into the USB port on our computer so we can read and write firmware to the TF card. This way we can flash our Raspberry Pi system onto it. Flashing the Raspberry Pi system is covered in the next video.